Okay. So for today, I'm going to continue with exporting data. So last time we already covered how to pretty much export any images from Google Engine to either locally or to Google Drive. And you can use the official way of exporting, like small size, but you can also have a workaround. So remember that pizza example, okay? You can either get a sliced pizza, if you want to get a whole pizza, you're gonna send an army to get all the pizza. And so that's for exporting just one image. I also show you how to subdivide into a fishnet and then use the fishnet to download slices of images. So for today, we're gonna continue with image collection. Okay. So this is where actually you might want to use Python than using JavaScript, because for JavaScript, if you're trying to export 10 images, there's a run button. I'm not sure if you ever tried it. There's a run button in the task manager that you have to click many times. So depends on how many times you images you want to export, you need to click 10 times. So there's a button on the JavaScript code editor. But for Python, it's just one line, it's automated. So this is a nice thing about uh, using Python. So here, just quickly show you. Okay, so I get an area and then I filter the images and then filter the point for the images in 2008. Okay, well, it's all the same. Anyways, the same location, but oh, 10 years. So I'm gonna mix. Why? So it's like 2008. So it's 10 years for a single point. And then so here, these are all the images that you see, right? If you want, you can always just add the images to take a look what it looks like. So let me create maps here, gmap.map. And then usually we create a map, find a location you like, and then just filter the images. So in this case, I'm just going to maybe image equal to collection dot first, right? You can always look at just the first image, then map dot add layer, okay, image, and then you can just m dot center object. If you don't want to like figure out what's the latitude longitude, this is usually just the fastest way to figure out. And take a look. Okay, so by default, this is the image that we get. So this is probably in 2008, right? Up to 2018. So in total, we have how many images? 1, 2, 3, 4, 5, 6, 7. So if we increase a little bit, I think we now have more images. So you can increase maybe 20, 24. You might have images for 2003. I'm not quite sure, but take a look. So now we have more images in here. And if you want, you can just visualize its individual images. So this is what it looks like. You can also just use this one, just type collection and then just type enter. It should show you the list. Okay, so if you want to see, for example, the specific date or images, you can do that. So here shows you, for example, 2018. It's not order alphabetically, but 2009, 10, 12, 14, 15, 16, 17, 18, 19, 20, 21, 2022. Okay, so basically, we pretty much have images for every year. So for this specific location, we have a lot of images. So imagine that you already have a study area. You already find out the images, but sometimes you might have a large area. So you might have like a polygon, not just a point. Then you have to mosaic the images by year if you want to. I will show you more examples how to do that. But for now, let's just assume that this is what you want, right? We have, I'm not sure how many, over 10 images. If you really want, you can just click on doc size to figure out how many we have images, right? So in the previous lecture, we covered like how to export one, but you can also export all the images all at once. So here, you can specify the output directory. I'm going to change to maybe to NAIP because this is the USDA NAP images. So NAIP stands for National agricultural imagery program. So basically, it's acquired by USDA every 2 to 3 years for the entire US, mostly during the summer season. So here you can just use this function. So previously we used export image, now we use export image collection. Okay, and then just passing whatever image collection. It doesn't matter how many images it has. So it's just download all of them and specify your output directory where you want to output it, and also specify the scale. So for USDA name imagery, it's usually 1 meter or half meter resolution. Just as a demo, I'm going to export as 10 meter. 1 meter is going to take a little bit longer, but as you can see, it's going to show you in total, right? 12 images, and then exporting one by one. And so you should be able to find it under the directory. If you refresh it under NAIP, take a look, right? So you have all the images all at once without having to manually go through them. So let me open here just to show you the file size, right? So usually it's just 1 to 2. This is only like one megabyte, okay, because it's low resolution. If it increase to 1 meter, what would be the file size increase? How many times? If it is 1 megabyte, 10 meter resolution, how big is the file size for 1 meter resolution? How many? 100. Right? It's 10 meter by 10 meter. Inside there, you have 100 pixels, one by one. So it's going to be 100 megabytes. So it's going to be it's much larger. Anyway, this is just a demo. So you see, now you get all the 10 images. So imagine in the future, if you're doing a study for a specific area, you know what images you want, and you want the time series. One line of code, right? You get all the images you want. You just need to filter. So first you need to just figure out what images do you want. They say, no, this one you want lane set, right? So you can do lane set or Sentinel-2, whatever, like using the code block, and then filter your area, filter the date, or even filter the cloud coverage, for example, right? And maybe you get 300 images. Yeah, just one line of code. It doesn't matter how many. It's going to download 300 images. And by default, it's all using the name, basically the system index. Is if you show this one here, like the name USDA, blah blah blah, and the last portion of this one is the name of the file. So basically, you can think about it's a geotiff in there. So basically, the system index. This one is basically the unique ID to the image, and the start date. So this is basically just the seconds since 1970. You can convert it to other date if you want. So let me show you. I mean, there's a nice function I think called gmap image image date. Yeah, image date. So here, if you want, I can do just passing the collection, and take a look. It can show you basically converting those dates from something like this. Usually the start and end usually the same at the same time. So converting to some format like this. So 2018, 19, 20, it's not sorted alphabetically, but at least you can see now it's much more clear. Maybe you can, there's a sort function, I believe. Let me see. Okay, that's better. So now you see all the images from 2009, 10, almost every year. Right, so 12 images, couple seconds, you get all the images you want. So just use this approach to download any time series images for any location you like, and it should be really simple. So this is using a point, but you can certainly also use a polygon. So let me show you here how you can actually do that easily. Okay, so they say, okay, I want maybe images for this area. Okay, so this is usually going to be much larger. It's not going to be one single tile. Maybe it's too big, so maybe for this one. Okay, oops, let me remove this just to show you how you can download images for example, for the entire Tennessee. Of course, you don't want to download 1 meter for Tennessee, but I'm just showing an example. So you see, here, this is the area I want, okay? Based on the shape, I know this is going to cover multiple tiles. So if you want to download images, for example, for every year, you probably need to mosaic them, right? So one thing you can do is to use a shortcut. This whole lot easier. If you want, you can write the code by yourself, but Gmail already have those shortcut that makes it easier. So for now, let's just see, okay, user RI, you can see polygon, right? So I'm going to use this polygon to filter the images or create a time series. So here you can just use this function. I say ts equal to gmap dot. I think there's a NAIP time series. Okay. So what this one is doing is just giving RI and the start year, the end year, and whether you want to just RGBN, so maybe red, green, blue, and near infrared. So in the early days, they only have images for RGB. But since 2009, they have images also near infrared. So it's up to you. If you want a longer time series, you don't want to use near infrared. Otherwise, you will filter those early days. So in this case, what we want is like, I'm going to passing this RI, the rectangle that I just drew. And then for the start date and the end date, you can leave it as default. No, maybe not as default. Yeah, end date, if it is default, it's going to use the current year. So it'll be 2024. But for the RGBN, I want to choose to true. So that means it's only going to require images that has 4 bands, okay? And hopefully, no RI, it's map.user RI, okay? User RI on it. What? USER. See? So now it's done. And we can take a look. So if you just print out TS, take a look. 4 bands, images, right? Properties, system index. Right. So how nice. So now it's done. So you can just use the same code block. I'm going to copy this one. And I'll show you how you can add it to the map. So we already create the time series. So now we're doing this one. So the image would be, instead of collection, it will be TS, right? Because we already create a time series. So now we're adding this one, but we probably maybe, yeah, I think should be fine. Just add this one and see how it works. See? Is it the one we want? If you go back to here, right? This area here, right? Is exactly this is about. So now basically you have images automatically mosaic. So if you're working on large area, if it is USD and net imagery, you can use the NAIP underscore time series. If it is a very general set of images, you can use the create underscore time series. So that one can apply to any image collection, not just for NAIP. So what you can do, like what I'm showing you here, so it'll be gemap dot create, oops, dot create here, okay, create time series. This is a Swiss knife, like a one shortcut function. You can create time series for any data. So all we need is passing image collection. So think about if you're doing lane set, okay, let's say you want to create lane set time series for the entire Tennessee. For every year, one line of code. For every quarter, still the one line of code. So all we need, just look at the parameter to just passing the collection. So this collection can be something that you already filter the date, you already filter cloud cover, whatever, right? A subset of the images. And then it's a time series. So in there, you can create, it depends on the date. So for example, you can do it by year, by month, by quarter, and then the reducer is median. So imagine if you, after the filter, you have 10 images for that year, it's going to apply the median filter to create one image for every year. Drop empty means if there's no images meet the criteria in that year, you will drop that. So basically, in this case, if you go back to the example, we have like 2009, 2010, like 2011 is not there. But if you say drop empty equal to false, you will create a dummy image. Is 2011, something like that. Okay, so this is a very nice function. If you know how to use it, it will make your life so much easier. So essentially, you can create time series for any location, for any temporal frequency. Of course, your data need to support it. If you're trying to create like daily images using lens set, it's not going to work because there's no like daily. Oh, okay, you can do, but you're not going to get daily. You basically you're getting every image you get, but you're not going to get 365 lens set images for location because the set doesn't do that. But for modis, right, if you have daily, you can do daily. So take a look at this one. So nice. Now you have the entire images for your area. It doesn't matter how big it is. It can be as big as this. So for example here, let me show you. Okay. Let's say, okay, I want images for Tennessee. You are welcome to use the state boundary to filter. Or I can just simple like draw this one, right? Maybe let me go back to here. This one. Okay, maybe that's fine. So I'm going to, for example, here. Right, this is the entire state of Tennessee. And I want to create time series. Look at this one. It's the same. There's no difference. The source code still looks the same. And now this one work. Don't send to this one. Otherwise, it might be a bit slow. So what I'm doing here is that I create a time series. This one is a little bit longer because it's thousands or tens of thousands images in there. So it's going to be pretty slow. So because it's 1 meter resolution. But if you do it for example, using lens set, it should be pretty quick. Should be a couple seconds. Anyway, it's done. And let's take a look. You just need to be patient. But eventually, I didn't clip to the location yet. Oh, this is just the first year. So that's why you only have a small portion intersect. But in the next year, you might have more, but at least you can see. If you zoom in, this is the highest free resolution image you can get for the US for any location. So take a look. No matter what you do, I mean, this might be a valuable data set you want to consider. Again, this is just 1 year, right? I'm not quite sure what year it is, but you can try it for other years. So here I can do the same thing. I can just print out TS. Again, it might take a little bit longer, but this should give you some idea about what date of the images are available. And it's certainly not every year. If you want, you can select the second year image to see which one has the most coverage. So take a look here. Yeah, this will be a little bit hard to see. Image date. Somewhere in here, you can use like EG state to get it if you want to. Anyway, so now give you a location, give you an image collection, you can create a time series by date, by year, by month, by quarter, whatever you want. So if you're doing some remote sensing, this is the best way to create a composite. And of course, you can export this one to Google Drive, or you can export this to assets. Asset means it's getting back to your account, but the image, the data stay in your account, so you can still utilize the cloud computing power. Once you export data to your local computer or you export to Google Drive, it's out. You cannot utilize cloud computing unless you upload the data back to Google Sensing. So those are just something that you want to pay attention. Questions? It's easy, right? So now you know how to download images, how to create composite. And this is where the power of cloud computing, of using this, because it doesn't matter how big is your area. Is it the state, or is it the whole country, or is it at a global scale? It's the same line of code, and you can run it really, really fast. Traditionally, if you're doing, for example, for the entire Tennessee, good luck downloading those data. It's tens of gigabytes. Now seconds. Okay. Next, let's talk about exporting videos. So basically export, I think, is a GIF animation. And in this case, you can export this one to your Google Drive. It might take you some time, but again, you need to check the task manager. And I'm working on basically in the future, you'll be able to check your task manager directly within Notebook without having to go to your Google Drive. For now, after you finish the export, after you run the code, you will need to go here, code editor, and then log into your account. And then under the task manager here, you're going to check from here. So now you see it's exporting. You're going to take a couple minutes or seconds to export the data. So basically, you can export that as a video file if you want to. But most of the time, you can just use the time lapse. So if you use the create time lapse, you can also create an animation for any location you like. It's going to take a while. We'll come back to check that later. The next example, exporting thumbnails. So first, let's take a look at this. Let's see what it looks like. Oh, is it done? Yeah, okay. And then let's edit images. So here, for example, I'm starting somewhere in California, and I know it has a lot of landscape images for this area. So you're trying to create some maps or create some animation. But if you're trying to download the entire animation directly from Google Staging, it has the file size limit. So you will see the resolution is, the quality is not that good. If you really want high quality, then the better way will be exporting the thumbnail. So basically a small subset of images, but you export all the thumbnails and then you can create animation offline rather than ask Google essentially to create the thumbnail because it has the file size limit. So in this case here, we already create the image collection. For example, filter sort by cloud cover, and then I select the top 10, the least cloud coverage, the top 10 least cloud cover image for this area, and I'm showing you the first one. So here, in order to make it consistent, so I also passing a rectangle. So basically, I just want the images for a specific area. Of course, you can just simply draw a rectangle because keep in mind, landscape images for the same location for this one, it's not always the exact same location. So you'll be a slightly offset, sometimes to the left, sometimes to the right, sometimes to the top. So that's why last time, if you remember the quiz, right? I show you like the image count. You will see that in the overlapping area, it's not always the same size. Sometimes we'll up, sometimes down, to the left, to the right. But in general, it will be centered around this location. You're welcome to check the second image you add that. You will see it's not aligned perfectly because the orbit is a bit different every time. So with that, take a look at this one. You can just use gmap.get image thumbnail. So this is just going to get one thumbnail. So for this specific, so it's basically maybe a rectangle somewhere there, and then you can take a look what it looks like. So it's going to take some time. So essentially it's downloading, not downloading the GeoTIFF because GeoTIFF is much larger. This one is downloading just the JPEG. So it's much faster. So if you need some images, you want to take a look and you don't want to download the large original file. You also don't want the GIF animation because the quality is too low. You want somewhere in the middle. Then this is the way. So you see it's already downloaded, and let me open here. Go to the folder, and so this one you see 345K. So it's not too big, and if you open it, it looks like this. Okay, so it's a little bit better. I mean, you can zoom in a little bit. Right? Not bad, right? It's certainly better than the time lapse because the time lapse you're not going to get this high resolution. Usually it's pretty small. So this gives you a pretty good picture. For example, you are starting San Francisco, you want some images, right? So now I have one thumbnail and make sure that it works, and the resolution and also the visualization, everything looks good. Once you are satisfied with that, then you can just there's also a function here if you want to show the images directly within the notebook, just gmap.show image. And earlier, right, I show you there are in total 10 images available, or we select the top 10 this cloud coverage. And so now if you want, you can download all the image thumbnail. So like I said, similar to the create time series, you basically create an image collection. So here we just get image collection thumbnail. So basically we get the thumbnail for all the images for this collection. And this is where you want to output. And you can specify how you want to visualize that. And this is very important because for if you're downloading original GeoTIFF, usually we don't specify the visualization. But if you're downloading a thumbnail, you need to see what you want it to look like. Otherwise, it might be just totally black. And the dimension and also the region. So here, I'm going to change this one to maybe thumbnail. Okay. And I'm going to run it. See, in total, we have 10 images and I'm going to download one by one. So in this way, you can get image decent size. It's a JPEG, so it's not geospatial data anymore. It's just kind of like a screenshot. But it gives you images for all the overall images. So you can see here from 2015, 2015, 18, 18, 21, 23, 2013. Is it? No, it's not ranked alphabetically. Okay, never mind. So basically, you get all the thumbnail. But if you sort, for example, here, look at the thumbnail. If you sort this one, it should be alphabetically, right? Here, oops, not this here. Okay, so from 2013, 13, 15, 18, 19, 20, 20, 21, right? Now take a look. You can open it. And so here, this is where you can see the images pretty clearly, right? And then you can skip to the next one. It's better, certainly better than just the GIF animation because you can zoom in, you can zoom out. It's the quality should be much better than for the GIF animation. You cannot zoom in, right? So this is how you can download all the thumbnails together, and then you can create. If you want, you can create the animation by yourself. If you want, and so here, let me show you if you want to. I think Gmap has a. Okay, what's the function? Gmap dot create GIF or something? No, maybe Mac. Yeah, Mac GIF. Okay. And so in here, it's pretty simple. So all you need is just passing the directory. So earlier we downloaded to the directory is the thumbnail, or you can pass in a list and specify where you want to output. Okay, it's all the JPEG, how many frames per second, and whether you want to loop or not. By default, it's looping. So let's just try it out, see if it works. So it's under the thumbnails directory. Okay, and I'm going to export to Lancet GIF, and then the frames per second. I'm going to maybe 3. Okay, so basically I have 10 images, 3 frames per second. Essentially we have 3 seconds. The GIF animation has 3 seconds, and let's see if it works. It may not, but let's try it out. So it's under the hood, it's doing all the work and then merging them all together. Okay, it's done. Good, let me check. So Lancet GIF, 5 megabyte. Let's open it. Nice. Okay. So now you basically downloading the thumbnail rather than ask Google sends you to create the GIF animation because the file size is going to be much more limited. And here, if you zoom in, right, you can actually see more details than you download it directly. Right. Of course, there's not much changes, but it's quite interesting, right? So you see the ships on the ocean. If you have some higher temporal frequency, you can actually check those stuff. Okay, so that's kind of the way that you can download images. Whether you download the original image, GeoTIFF, or you download just a thumbnail, JPEG or PNG, and if you want, then you can create animation by yourself. Okay, so this is how you downloading raster data. So you have image, you have image collection, you have we also have feature collection, and you can download to your local computer. You can download to Google Drive. So I'm going to talk about how to download vector data. your computer. And this one might be a little bit slow if you, let me see here, entire Europe. I think we can try another example. This one might be too slow. Okay, put the entire Europe in here, right? So you have all the countries. I think I'm going to just select the first one so that it's not too slow. So I'm just going to first, let's see if it works. Where's the first one? Hello. Outside the extent? Oh, okay. Good point. So maybe let me center. Yeah, it's already center. I'm not sure. Let me make a much larger number. So exporting, not even here. Let's do this to filter. Anyway, the reason I want to select small one because I know exporting vector data is very slow. So sometimes can take a while. So what you want is just to maybe download a small subset. And let me try out somewhere. For example, let me click. And how about just find a small country? How about this one? What is this? Okay. So let's figure out what's the name. How do you filter it? Okay, so I'm gonna click here. How about this? Just the country CO KB. Okay, country CO KB. So it'll be like this. I'm gonna come back to here. I don't think we need the filter anymore. So I'm gonna do country CO. Okay, uppercase KB, right? Oh, county. Okay, COUNTRY. Oops. Okay, nice. So now we only have one polygons. So essentially, if you already have some data filter and you want to export some vector data from Google Search Engine, there are a couple ways. You can export as a shape file directly. In here, FC, right? Right now we only have one country. You can change the name if you want. And right now, just use like Europe. Okay. And the selector means if you would just for the vector data, if they has too many columns, you just want a small number of columns, then you can just pass in a list of column names. Then you just export those. So here, if you look at this one, refresh and then find Europe, right? It's here. The shape file is here. So you can, if you want, you can add that one back to Google, the map if you want to. You can export, just use the general export vector data and then just give a file name. So it depends on the file name, whether it's a CSV, a shape file or a GeoJSON, it will export correctly. So basically, this function, you can replace this one. It's the same. Under the hood, it's going to figure out, depends on the file extension. It will call the other function. Or you can export as a GeoJSON, right? See? Done. It's pretty quick. So on this one, and the GeoJSON is here, right? And you can open it, you can take a look. So it export the entire polygon and its associated metadata, description, and other type of stuff. So it's quite useful if you want to export some vector data from Google Search Engine. E to CSV means you only export the attribute table. So you don't export the geometries and also the coordinates. So here, refresh, and then Europe, CSV, here, right? Double click, open, right? Because we only export one, click, just one country. So you don't see a lot of stuff. We have 4 columns, right? So this one doesn't have the geometry. So it doesn't have those coordinates. Otherwise, your file will be like something like this. Because if you export CSV, there's no point of getting all the coordinates in the CSV. And you can also export as a geodata frame or as a data frame. So if there's a data frame, that means it's just a table. If a geodata frame, that means it's still vector data and the coordinate, the geometry is here. So think about the GeoJSON we export earlier. But this one basically export as a GeoJSON and then converted one into a geodata frame. And one nice way, if you don't want to, you can also use map.gtf to add that one back to the map. Or if you want just gtf.explore, this allows you to view the polygon directly on a folder map. Right, so pretty nice. So now you see why it doesn't have the base map. Supposed to have a base map. Anyway, right, so you can actually visualize what the map looks like using here. Maybe I can add this one. Let me show you here. Right, I can just do map dot. Is it map uppercase or lowercase? Uppercase. If you use uppercase, map dot add layer. Oh, not add layer. Okay, sorry. Add GTF. Okay, and then just passing the GTF somewhere here on it. Hope it works. So basically, I export it and then oops, and then get it back into the map. Cannot transform set the CIS for the object first. Okay, so that means it lose the CIS. So GTF.CIS. Yeah, sometimes it is none. It doesn't know how to plot it on the map. So what you can do, it'll be like this. EPSG 4326. So that means it's CIS coordinates. Let's run again. You see that? So now basically you have two data layers that are exactly the same. This one is Google sending. This one is the local one, right? So if you hover my mouse, you will see it's popping up here. That means it's a local file. For Google sending, you cannot hover. You need to click your mouse on the map to be able to get the value. But this actually shows you how you can export data from Google sending, and then locally you can do some manipulation with the data, and then can add it back to the map. So it's up to you what you want to do. But these are the same representation of a country, but it's different format. So it's the local format and the cloud format. So you can export any data you like. Like I said, it's quite limited. So if you have a polygon or some software that's quite complicated that contains tens of thousands of points or vertices, most likely you cannot export it because it's too complicated. It's going to take you a while. You can export to Google Drive. That one has a larger file size limit, but you need to wait, so it's not instant. And speaking of that, let me come back to here. Like we export the video earlier, and let me open in Google Drive, see if it's done. Which one? Yeah, so MP4, right? So this is the one that we did earlier, and let's open it. Yeah, so this one like a lot more, all the images, a lot more, but it's a small file size. You see the resolution is not that good, right? But at least you can create this kind of video for any location, for any animation, any area you like. Questions? Next, exporting maps. So Google Sensing is not cartography map making application. Is a computation platform. So if you want to create some maps, you can do a screenshot. There's also CartoPy, another package, but we haven't had time to cover. But sometimes if you want to export maps, you can do that. There's a function called map to HTML, but that one does not work very well. I'm not sure if it still works. So for example, right, this is the map, and then you can just map to HTML. They won't allow you to export the map to HTML. So let me see what's the file name, my map HTML, and let me see if you can open it. Sometimes it doesn't work because I leave it. Oh, okay, it works. That's fine. So this might be helpful if you want to, for example, actually create something you want to share with other people, or you want to make available to the public. So they don't have to have a Google Sending account. They don't have to run the call. This might be something you want to consider because, for example, this is like 10 meter resolution. It's pretty big, but you see, it's you can export the file pretty easily and then share with other people. No. So this is volume. So the like changing opacity stuff, it won't work here. Yeah, you can turn it on and off. But keep in mind, the data layer will disappear like 24 to 48 hours because the layer is temporary. So if you send to someone else, like you need to see that very quickly. After 24 hours, you cannot see. So you can go back to check, for example, for your lab assignments, for the things that you run on Google Colab that you submit, quiz or lab assignment. If you check back to after 24 hours, the data layer will not show. Do you notice that? It's because all the data layer are temporary. Otherwise, it's going to take a whole lot of space. So everything is like they have the data, everything else is run on the fly. So this is only good if you want to, for example, after submit assignment, if I really want to see the result, I need to grade it within 24, 48 hours. Otherwise, the data will be gone. I need to run again. So this is kind of a workaround, but if you really want, you will need to like create web apps. I certainly have something that I can show you here. For example, like I also have like this is leaf map, like but you can also add some Google sensing data. So if you see here, like PM, state, might take time to load, right? So these are also Google sensing data layers. But I regenerate the data layer every 24 hours. So it's automatic. So in that way, when you go to the web app, you will always be able to see the data layer. So this is, if you want to create something that's make it accessible, then you might want to try out some of this example. So imagine that you have do your research, do your stuff, you generate some data products on Google Sensing. You want to create some web apps that allow people to use rather than, oh, okay, here's the source code. Then this might be the way. We don't have time to cover this, but I just want to let you know it's possible. So if you want to do that, certainly you can make all the data layer. This one is better than the one I show you, like just the layer control. This one still works. So see here. So all the tools that you use with um, Gmap, it still works because this is based on IPyLib. This is not Podium. So if you click here, I can go to the inspector tool. I can, oh, this one is not Gmap. So if you want the Gmap, I think I have another application here that I can show you somewhere here, Gmap. Look at this one. This one is based on the interface that you see the same on Gmap. So here I'm going to click, go to inspector, right? So I load the data layer, see this, right? Everything just works. It's the same that you see on notebook. And if I click my mouse on the map, see, the inspector still works. So this is a better way of doing interactive mapping applications, but it needs some time to set this up. But once it's set up, it's pretty useful. For example, also the split map. So here, right, and I can select the drop-down list, something like that. But if I export as an HTML, it won't work. It will just be something like this. There's no control because everything you're doing here requires Python and JavaScript. So you need kind of a front end and back end. It's a bit complicated, but here, map to HTML. Oh, I think. Oh no, that one is not export. That one needs some source code. So if you want, you can go here, home, and then Hugging Face, file, pages. So this is basically a Docker file, basically a virtual cloud environment. And if you see in here, it's a bit different from like Java, the one you do in Jupyter Lab. So you need to spend some time to familiar with this. I also have video if you want to do that, but you can just clone the environment and then here just add whatever data layer you want and then just use this template. It works just fine. But it's kind of a new web mapping framework, kind of similar to Streamlit and others, but this is the one that support bi-directional communication. Means you click on the map, you will get a coordinate, you can send back to your program, do some computation, return the result. So this is a whole new way. This is only available a couple months ago, and was super excited. That's why I create so many apps that you can actually interact. Now, in the past, it's more like one way. You click it, you show the map, but you cannot interact with the map except zoom in and zoom out. But now you can click the map, you can query, you can use inspector, you can do all kind of stuff. So it's super fun. And for example here, right? So this is similarly, you can build on top of a leaf map and G map, right? So not sure if I showed you this one before, right? So this, imagine, right? This is just some of the polygons. You have the data. So if I click on the map, right, it's going to get your coordinate. It's going to run some computation and find the intersection in the database, right? And then you can simply just um, here, right? You can navigate to any location, and then you can turn this off. I can click the split map. I can do things and do that, right? So this Gmap also supports that. So under the hood is using those packages, but it's a lot more powerful than just exporting as a static map. Okay, that's pretty much it. And the last one here, if you have time, you can try it out. But I think right now most of you do not need this one yet. So this is more like using the high volume endpoint, means you can download 1,000 images within minutes. Because the other method I cover is more like if you download a large amount, like the image is big, you can download a couple images. But this one is for like downloading small tiles, and then download thousands of those, because you might be interested in doing deep learning. You need to so-called download the pages. This one can download very fast. And in here, let me show you if I can. I didn't install this one, so there's a retry. If we can take a couple seconds. So this one use some additional packages, and on the Conda, I just want to show you what it looks like so that you can. So I'm gonna pick min store retry. So this is like the same as the PISA example. You're gonna download 1,000 small images all together. If you use the other methods that we just introduced earlier, it's going to take you a long time. But this one is like very quick. So let's run it this one. And you will notice here, we're going to initialize using the high volume endpoint. So high volume endpoint, that means it's not for computation. It's more like you're doing batch processing. So you're going to download images very quickly. And let's quickly run through this example here. Oops. Map. Okay, so I forgot the map in here. From the code, so gmap dot map. Oops. Okay, so now I can run this one and just show you here the images, filter the location, and then I show you the images. This region. Okay, so for example, I have this image. This is pretty big, and you're trying to do deep learning and machine learning. So usually you need to have those slices, very small images. So you're going to, for example, create random sample on these images and download all of them. So here I maybe try to do images, for example, download all of them to this directory, and there are a bunch of parameters we don't have time to go through, but I just want to show you what it looks like here. And so this is using so-called multi-threading. So we're going to, yeah, it may not work on Windows. I remember if it doesn't work, then you can try Google Colab. I think if I remember correctly, Windows has some issue with this, but it should fine with on Google Colab and also Linux or Mac computer. I think the multi-threading is not well supported on Windows. So when I run it on my computer on Linux, it works just fine. But this is the fastest way you're going to get tiny images, tens of thousands of them, very quickly. Use this one. But if you want like large images, large file size, then use the download EE image collection, or download image tile, parallel, something like that. So those cover all the things that you need to know in order to download images. So whether it's image collection, pixel collection, raster data, vector data, now you have it. So you can download anything you like from Google's engine without having to go to other data portal. Okay, so that's all I have. I'll see you on Friday. So on Friday, we'll get into some Google's engine applications, how you can really do some cool analysis using Google Search Engine. And there might be a quiz. Okay, so be prepared. Or maybe next Monday. I'm not quite sure yet. You will know when I posted it, but I'm still thinking about it. We have 10 quizzes, right? We just finished 5, so